Gotcha. Alright, now we're looking at A. Only A. And A does two things. I'm going to tell you right now, right? Sometimes A is negative, and it makes you go down instead of up. And when it's bigger than 1, it makes you skinnier, right? And sometimes A is less than 1 and positive. Well, less than 1 makes me wider, like this, much wider. And so we'll describe how 1/4 x and negative 2x. Alright? 1/4 made it wider. Negative 2, alright, reflected over x-axis. That means it went bloop over this axis right here, flipped, and was thinner. Alright. What other transformations can occur with values of A and A of x when it's negative? Alright. So we'll say negative or positive. Negative opens down. Positive opens up. Right? If A is greater than 1, it's skinny. And if A is less than 1, it's fat. We're going to call this a vertical stretch and a vertical compression. Alright, we got a little bit more. That is it. So look, I'll show you what this means. Alright. So we're going to sketch this graph. There's lots of ways to do it, but I do know it opens down and it's got a vertical stretch, so I'm going to write it. Reflect over x-axis, and that's not a vertical stretch. A is less than 1, so it's called a vertical compression. So A is 1/2, right? A equals negative 1/2. So that means the very first time I move over 1, I only go down 1/2, right? Instead of going down a full 1, which gets me a little bit fatter than what you're used to. I came over here and say A equals 4. That is a vertical stretch. That means the very first time I move over 1, I go up 4. And this is 1 right to there, over 1. And so we see this graph got a lot skinnier because we're stretching it. We're literally taking something that would have stopped here and we've stretched it up from the x-axis. That's what it means. 4 times further than it would normally go. Why is it important to notice both direction and distance that a point has been translated when going vertically and horizontally? Wow, right? Why is it important to note both direction and distance? Well, I would say to accurately graph. I don't understand that question. How does knowing a point on a graph other than the vertex help you find the value of it? How does knowing a point on the graph, well, it allows you to see the trend, right? Or stretch value, stretch of the graph. So H and K tell us our vertex, but A lets us know what's the next point. When graphing an absolute value function, how is this and this related? We're going to say negative A, right, reflects over x-axis, or just points down, right? Points down. I'm going to sneeze. Here we go. Always twice. Alright. How would the graph of the parent function be affected if h was greater than 0? It would move right. If k was less than 0, it would go down. And if a was greater than 1, it would stretch. And there it is. We're done. Talk to you guys soon.